Even though our chambers look different, the reaction process is exactly the same. And so this is all proprietary right from the optics through to everything that's in there. But the mechanics of it is identical, so that we've got our oxidizing, as you saw with our table, our source. So when contaminated air enters into that chamber, there's enough energy in there to decompose or pull apart, like we said with that train illustration, uncouple any VOC that goes through there. We also have more than enough energy. All we need is 5 milliseconds of exposure time. Any microorganism going through there has received more energy than the cell wall can withstand. So that's good to know. So we hold them in for about 180 to maybe 200 milliseconds. So we've given it way more time than it needs to actually be sterile. So we know that what's coming out of there is the life form cannot replicate. The interesting thing about this, and having worked on the patents, is that we can affect change at a distance, and we'll show you what that equates to in the next slides. But when the hydroxyls exit, remember it's a capacitor, it's holding an electrical charge or an electron charge, so when it hits or gets into our clothing or a couch or something like that, it's going to donate energy that's going to control bacteria, virus, and fungal spores. And when it bumps into our VOCs, or those chemicals that are outgassing, it will neutralize those by uncoupling them or pulling them apart. So to affect change at a distance is the differentiator from us and everybody else that's out there. You have to put it all through their processor. It has to go through there. With us, we could have our machine outside the building and just create the hydroxyls and pump them in, and we can affect change at hundreds of feet away if that's necessary. So even though it looks simple, it is huge. And again, every good ideal that's taken from nature usually works very well somewhere else. So that's exactly what we've done. Again, a great example of biomimicry.